that we can continue. You can raise your hand or just any sign or icon. If you cannot see, you are still seeing the camera. Okay, the sign means we proceed. Okay, now the derivative from the first principle. First principle is a formula that it is prescribed there that you have to use it to find the derivative. Now, according to this section here, our derivative specifically, there are the steps. There are 4 steps that you have to follow so that you can understand this. The first step, you say that is to make the point that what is it? Oh, it has run away. Oh, Moses. Okay, the first step, you make it a point that you copy the formula as it is in the formula sheet. And then what is the formula that we know from the formula sheet? The formula that we know from the formula sheet, it says that the first derivative is equal to limit h to 0. Let's say limit h to 0. And then the whole formula is more like saying the graph of f as it is. And then in the brackets, whatever supposed to be x, we put x plus h. We put x plus h. And then the whole equation, we minus it by the graph of f, or the equation of f as it is, just the way it is. And then all in all, we divide them by h. That is the formula they're talking about, that says that you have to prescribe it from the formula sheet. Then the second one, we simply substitute wherever there is x, we substitute x plus h. This is what they are talking about here. Whenever there is x, we substitute x plus h. And then the third step, wherever there is a fraction, you must make sure that you find the lowest common factor, or lowest common denominator, or lowest common multiple on it, so that you can now work with the fraction as it is, and then you continue with the information as they are. And then the first thing that we will do, I will just look at an example so that we can understand how we work on it. This one, the aim here is to derive. Remember, the simple way of deriving is more like saying that an equation, if an equation is a multiplied by x, a multiplied by x to an exponent of maybe 3, x has an exponent of 3, and then the aim is to derive with the simple formula saying that a multiplied by the exponent which is 3, to say a multiplied by the exponent, a which is the coefficient of x, and then we substitute x as is, we put it back, and then we say the exponent itself, the exponent which is 3, and then we will say that the exponent minus 1. This is the aim of doing, or of derivative. Now, this is what we call a derivative, or this is the formula for derivative. Therefore, the simple way, for example, let's assume that a is 1. If a is 1, let me remove the screen and come back to here. If a is 1, then we will be having something like x to the power of 3. Now, if we are having something like x to the power of 3, and then we assume that a is 1 here, then our derivative formula will be like saying the exponent multiplied by a, and the exponent which is 3 multiplied by a, then x as it is, we rewrite it, then we'll have x to the exponent of the number as it is, which is 3, and then all in all, everything will minus it by 1. This is the principle, so that you don't have to question where is it coming from. Then in future, now we multiply 3 multiplied by a, or 3 multiplied by 1 in the brackets, it gives us 3, and then now x, we write it as it is. Then we simplify, or we calculate the exponent, which is 3 minus 1, which gives us 2. Now, this is the derivative of the equation, simply having like 3 x to the power of 3. Then the derivative is equal to 3 multiplied by x to the power of 3. That is how it has to be simplified. So which means, for example, if we are now to derive this, the whole thing from the formula of the first principle, which is now saying that fx plus h in the bracket minus fx divided by h, we are saying that now limit, wherever we see h, we put 0. The first thing, when we substitute this here is x, and then we find the information from the first principle. It means that the answer, they have to be still the same when we substitute. The answer will still be 3x to the exponent of 2. Now, I want us to take an example that is live from this one. Let's come back here on this part of the equation. Now, when we come back this on this part of the equation, now we are saying that, let me look at the example that we can now work on. The first one, number 1, it says that fx is equals to 5. And then 5 is a number. It's just a number without x. It means we call it what? We call it a constant. And when we derive constant, when we derive just a number itself without x, without any alphabet or a variable, when we derive that number, it just becomes 0. But if that number, it was an exponent, it has to multiply the coefficient of that variable if it's x. So here we are deriving what is part of x. If it's not part of x, we don't derive unless they stated otherwise, because simply when we derive, the formula is derivative in the form of, we are having, let's say, for example, derivative of 10 dy over dx. So it means now our equation, it is y is equals to, and then what are we deriving? We are deriving the equation where there is x as a variable. That is where we see when they say dy over dx, it's simply saying that derive in a form of coefficient of x to an exponent n. Derive it in a form of to be now n multiplied by the coefficient of an, and then put x as it is, and then n minus 1. So you see what is happening here. This is just a simple general formula to say that, okay, let us work it out to derive it. And then when you know how we derive it, and then in this manner, then it's going to be obvious for you and simple for you to understand it. But then if it's just a number, like for example, number A, for example, the fx is equals to 5. Now, this is a principle that you must understand, that when we derive just a number, the whole equation is equal to 0. And then if it's equation like this one, after you derive it, we will no longer just write fx. We will have to put 1 up there, which will represent the f prime. That is where you will see f1 or f prime is equal to 0 if the example is in this format. The next question. Next question, we're working on the number 2. Number 2, which is the second one, number B, is written in a form of fx is equal to 5 multiplied by x. Then derive. When they say derive from the first principle, I will give you a technique so that you don't have to find it difficult in future. If you don't know of the formula, the technique of this one is that firstly, before you can use the formula, derive this thing with the simple formula of saying exponent of x now is 1. So say exponent multiplied by coefficient, we will have 5 multiplied by 1, and then exponent minus 1. So here, simple answer, we will have 5 multiplied by x to the power of 0, and anything to the power of 0 is 1. So simply the answer here is 5. So which means when we derive with the formula, we must end up finding the answer is equal to 5. Let's see if we do with that. And then wrapping this thing, this wrapper is too slow, so I will just use my hand. We will have our limit h, whatever is h, we say is 0, and then we only say limit h is to 0. We put substitute h. We put 0 where we see h only if our equation can no longer be simplified. Then we will say fx plus h minus fx divided by h. This is the formula they are talking about on the step 1. And then we now, the second part, we will say what? We substitute wherever there is x, we put x plus h on the first part. So we are having 5 multiplied by x. Now we're gonna have x plus h. Then all in all minus 5x divided by h. Now, why are we having this wherever there's x, we put x plus? It's a formula. It's a formula. So fx as it is, we just put the whole number as it is, but we multiply by negative because it's multiplying, it's negative. Then what do we do from here? We simplify. We simplify. When we simplify, we will have 5 multiplied by x, which is 5x, 5 multiplied by h, which is plus 5h, and then all in all, minus 5x. This is the 5x at the back. Then divided by h. Don't forget to write limit h to 0 in future. And then now we simplify. When we simplify, group the like terms as far as possible. Now we're having 5x minus 5x, which will give us 0, which means at the numerator, we will have 5h, then divided by h. You see now? And don't forget that limit h is to 0. When we put 0 here, the answer will be 0. So what do? We simplify first. So obviously here we can say h divided by h, which will be remaining with 5 over 1, the answer which is just equals to 5. Then the answer equals to 5. It is simple because this is just a part of a line equation. So on this part, we derive. That's why I said let's derive it with our simple formula first, and then after we see if we cannot get into the real answer. Now the answer are same. Okay. Do we have any questions before? Any question before we can go to the part?
No, I'm fine. No, I'm fine.
We still understand, right? Okay.
Yeah.
Okay, let's proceed to the next one. So this was the simple part of it. Let's find the difficult one, or let's increase the problem. When we increase the problem, number C. If you can see number C, let's try number C and see what does number C have for us. Number C is minus 5x to the power of 2. Now you can see they are increasing with the exponents. Now if they are increasing with the exponents, it's obvious that we have to just substitute as it is. Fx is equal to minus 5x to the power of 2. So examiner won't give you the questions that you can just easily take at some point. But then don't forget the principle. When every time they will say derive from the first principle. Now, when they say derive from the first principle, is for you to state the formula to say that limit h to 0 is equal to fx plus h into bracket minus fx divided by h. That is the formula. Is there also in your formula sheet, will be provided to you. And then the next thing, what you do, wherever there is x, you put the first part, which is x plus h. So I will have limit h to 0, and then I will have minus 5, and then into bracket x plus h, and then to the power of 2. Remember, what here is supposed to be minus 5x, but there is no just x. Whatever there is x, I put x plus h, and then all in all minus the equation which is minus x squared. Why do I introduce the brackets? I introduce the brackets because it has a negative and there's also another negative, so that they don't contradict or I don't forget them. Then the next step is to simplify. When I remove this bracket, I will end up expanding, saying that is x plus h, then x plus h. Negative times negative is positive, so which means it will give me positive 5x squared, all in all divided by h. Then don't forget that limit 8 approach or is to 0. Then when I simplify this thing, I will say, I will start by putting 5 outside first and simplify this part. And then I will simplify the brackets one. I will just make the shortcut, which will be 2xh plus h squared, because when I say x times x, it will be x squared, and then x times h, it will be 1xh. Then again, x times h, it will be 1xh. Then h times h, it will be h squared. This is the h squared, this is the x squared. Then I will say xh plus xh, it will gives me 2xh. And then all in all, plus 5x to the power of 2 divided by h. Make sure that you don't forget anything when coming to this part. And then we simplify. You can see that we are now having 5 outside the bracket. We remove the bracket. We will multiply everything by 5. Then I will minus it by minus 5. We'll have minus 5 multiplied by x squared. Minus 5 multiplied by 2xh equal to minus 10xh, and then again multiply by my h squared equal to minus 5h squared, then plus 5x squared, all in all divided by h. Don't forget that limit h to 0. Then minus 5x, it will multiply, it will minus 5x, it will minus 5x squared. Minus 5x squared minus 5x squared, it's 0. Then Roshalaga minus 10xh minus 5h squared divided by h. Don't forget that the limit approach to 0. Simply here, then that is the part that we have to start introducing, which is the part of factorizing. Don't forget, don't substitute 0 where is h before we simplify until we can no longer factorize and simplify. Here there is h, which means h is our common factor. Then we open the bracket, we or remain minus 10x, and then on the other side remain minus 5h, because the h were h to the power of 2, and then divided by h. Now we'll say this h outside will cancel the other h on the other side, and then on top we'll remain with minus 10x minus 5h. Then what can we do with this thing? What we can do with this thing is to simplify or factorize by 5 outside, but it's still fine even if you can factorize by 5 outside, but then we can no longer do anything with the h and the x. Therefore, that is where we say that wherever we see h, we put 0. Then we will have minus 10x minus 5 into bracket. It's 0 because here is supposed to be h. And then when I punch everything on a calculator, I will have negative 10x. And then negative 10x is my final answer. Now, if negative 10x is my final answer, let's go back to the origin. I will just wrap this part so that we can now this 5 minus 5x squared using our normal formula, but not the first principle, which will say that the exponent multiplied by the coefficient of x, which is 2 multiplied by minus 5, which will give me minus 10. Remember, we are doing this so that we can know that the answer that we found at the end is correct. And then I will say exponent minus 1, and then which will be simply like saying minus 10 multiplied by x, then 2 minus 1, which is 1. Then this thing and the final answer, you can see now these answers are the same, and then your derivative is now correct, and you have simplified with the first principle.
Yeah.
What is difficult coming to here? You are free to talk anything.
You're from step number 1.
From step number 1.
How we get here? Yeah.
Step number 1 is here. Remember that we substitute. The equation was saying minus 5 to the power of 2, and then which means that wherever there is x on this, wherever there is x which is here, the first part of equation says that fx plus h, which means that the first part of the equation, wherever there is x, we put x plus h. So which means we will put 5 outside the bracket, and then in the bracket, we're supposed to be x here, we have to put x plus h. And then remember the x, it was to the power of 2. Now we will put x plus h to the power of 2. And then everything minus the whole equation of f, which is still minus 5x to the power of 2. That is what they mean when they say that limit, and also the first principle. And then from there, it's just a mathematical algebraic equation. We just solve, or we just express and simplify. Remember, anything to the power of 2, you express it into 2 ways, and then we do the mathematical calculations. The important part is to understand the formula as it is. I don't know about just that my space is small. Let me wrap this part. The formula of saying limit h to 0, and then f is equation, is the name of the graph, and then wherever in this bracket, if it was originally just be fx, so which means where there is x on your equation, you will now substitute x plus h. You will no longer just put that as equation, but you will put x plus h, and then yes.
Oh, I'm listening.
Yes, and then after the first part, you put wherever there's supposed to be x, you put x plus h, and then now you will minus with the equation as it is, which is fx. Which if it's fx, then you just put the equation as it is. Simply put it in the bracket so that you don't get confused with the signs, and then divide everything by h.
Okay.
Yes. And then if that makes sense, we can proceed to the next question, the next type of equation, so that we can understand more of them.
Okay, and then that side for fx, then we have to add the one that was given on top.
The fx
In place of fx, then we have to put this 5x.
according to the equation.
Yeah.
According to the equation here, we are given fx is minus 5x to the power of 2. And then according to the formula,
Yeah.
the formula that states that this formula, according to the formula, states that wherever there is x, there is x on the first part, you put x plus h.
Okay.
And then the second part, you just minus the whole equation as it is. You write it, but you multiply it by negative. That is why I introduced the brackets there.
Okay, yeah, I think I understand what you're saying.
Okay, then let me look for the question that it can be more interesting, which means challenging. Okay, let's look at number B, this one. Let's look at this one because it looks like it's difficult. But for the principle and the formula of shortcut, you can kill everything by just one strike. Okay, our fx is equals to minus 5x to the power of 2 minus 3x. Now you can see that you are having two x's here. X number 1, which is now x to the power of 2. The second one, which is now x itself like this. Are we clear?
Yes.
So which means now, what does it tell us, or what does it tell me and you? It tells us that now let's come back here, and on our equation, which is the formula limit h to 0 fx plus h minus fx divided by h. Now it means that wherever there is x on our equation, we put x plus h. Then I will start by saying limit h0, it's minus 5. Now here supposed to be x to the power of 2. But where there is x, I don't put x.
Yeah, okay.
Where there is x, I don't put x. I put what? I put x plus h. And remember, on the x here, it was having to the power of 2.
Yes, yes.
Now, if it was having to the power of 2, that is the first part. And then everything here, it's a minus 3. You see, if it's minus 3, now the 3 on the equation, it was having x. So which means on the first part, where there is x, I put x plus h. Now I am completing this section, which means the first section of fx plus h, the bracket, is completed. And then what follows after, it's minus. Now, if it's minus, then it's minus fx. And what is the value of fx? The value of fx, I will put it in the bracket, which is minus 5x to the power of 2 minus 3x.
Okay, yeah.
And then everything I will set by h.
Yeah.
That is the important part. If you can know how we then simplify and we substitute on this section, you will know. The first x appear here on the x to the power of 2. The second x appear here on x. So which means for the first part, we say that when we say fx plus h, it means on the x squared, there is x plus h minus 3x. It means again that on the second x, there is x plus h. We didn't as fx, we are still here. So if we are still here, we started and we satisfied this part by putting this one. And then after we simplify, after we substitute, we say minus. That is where we are going on the formula. And then we come back and we put this part, the equation as it is. Then from here, all in all, divide by h. Then we simplify.
Okay.
Then when we simplify, we'll say everything in the bracket to the power of 2, we simplify them. Then remember our 5 minus 5x squared on the first part. So now we'll just simplify it so that it can be quick and easy and allow me to have space. Then the first part in the bracket is this one, and then of minus 3, it's gonna be minus 3x minus 3h. And then all in all, negative times negative is positive 5x squared. Negative times negative is positive 3x. Then, sorry, 3h, not x. Yeah, yes, 3x. Yeah, I'm right. 3x. And then all in all, divide by h. Not forgetting that limit h to 0. And then again, I will multiply by 5 in everything in the bracket. To simplify, I will have minus 5x to the power of 2 minus 10x to the 10xh, then minus 5h squared, then minus 3x, then minus 3h, then plus 5x squared, then plus 3x. All in all, divided by h. Now, someone can say this is confusing or complicating, but if you can understand the step of substitution, and then we go to algebraic expression with expressed by simplifying, going to this part, it's gonna be easy for you. The important part, it is to know how we then get to this part, step of substituting, because if you can fail to substitute, everything that you will be doing from that point is gonna be wrong.
Yeah. Okay. You know what? Can you please go back to unpack third part?
The third
Because
part.
I can see it's been a while not doing a maths. So when you come to the point where you find 10xh, I'm like, now I don't know.
Okay, you mean how do we get
Yes.
Actually starts here at 2xh.
Yes, please.
Okay, let me just put this statement. Because I skipped the one step, yes.
Yeah.
Okay, don't forget, I won't write limit h to 0 because it's going to take a lot of space. Then I'll have maths, and then I will have x times x. It's gonna be x plus h, x plus h. This is the part where it comes.
Oh, okay.
Remember, or this is x plus h in the brackets to the power of 2. It is, or when we express it, is 2 of them.
Yeah.
Are we clear? Good. Okay. Then let me wrap this.
If I can still write like that on exam.
In exam, you don't have to skip any step because you don't know the step they want to mark for you.
Okay.
So from there, that will be into bracket x plus xh plus xh plus h squared. And the minus 5 to the minus 5 into brackets plus 2xh plus h squared comes from. These two are alike, so we just add them.
Yeah.
So that is where 10 comes from. 10 comes from saying that minus 5, because it's outside in the brackets, it multiplies everything inside the bracket. It multiply x squared, it multiply 2xh, it multiply h squared. So that's why we are having minus 5x squared. We are having minus, we are having minus 5h squared. Then everything is the other part outside the brackets.
Okay, yeah.
Then continuing from this part, we group our like terms. So we are having minus 5x squared, and also we are having plus 5x squared, which means they are the same, they crush one another. And then again, we are having minus 3 and also plus 3x. They are removing one another. Then what are we going to be remaining with? Will be remain xh minus 10xh minus 5 minus 3h divided by h. They will remain this one and this one and this one. That's the remaining parts. Are we here?
Yes.
So which means we worked with what? We worked with x. So we are remaining with h. Remember, the last step before we substitute by 0, wherever there is h, the last step, it must convince you to factorize. So which means you can factorize the numerator, which is the top part on the fraction. In most cases, or always, with h on the top. So there is h here, there is h here, there is h here. You just remove one h there and then write in that remaining without h, so that you can see which, if they are without one h, what will happen. So I will have h multiplied by, in the bracket, minus 10x minus 10x minus 5h minus 3. Why is it minus 5h? Because the h here on minus 5, they are to the power of 2. So if I am saying it's 1h, then it will be h multiplied by h. They will give us h to the power of 2. That is why now the h is 1 there. Then now the h on top, it will always cancel the h at the bottom. And then remaining with this one, limit h to 0. We remain with minus 10x minus 5h minus. Then the next step, we can't do anything. We just substitute wherever there is h. Then we will have something like 0 multiplied by 5 minus 3. Because minus 5 is only one that carries h. Then we only put it on this one. And then mathematically on the calculator, anything multiplied by 0 is 0. Then I will remain with minus 10x minus 3. Then which means this is my answer.
Okay.
So when you write the answer, there is no longer need of writing the limit, but there is a need of writing the f prime, or the first derivative, derivative number 1. Are we clear here?
Yes, I understand that.
Good. And which means that going further upwards to prove that the equation is the same, let's use our bypass or the shortcut to show that the equation is correct by saying that whatever thing on the formula of fx or on the equation of fx, if it is having the x, it means it is meeting the requirements of saying that whatever exponent of x, we multiply the coefficient of that x with its exponent. So here we are having minus 5x to the power of 2 minus 3x. So which means now we are having two parts. The two parts is the first part of minus 5x to the power of 2. The second part, which is minus 3x. So we are going independently, which means when I'm going to use the formula of nx n minus 1, I'm going to use this independently, n, which is the exponent. Now the exponent of the first part is 2. Then I will have 2 multiplied by the coefficient of x, which is 5. And then writing the x, the exponent of 2, the exponent, we minus it by 1. That is the first part when I mean independently. Then the second part, I will say minus, and then I will have the exponent of this x, 3x squared here. If there is nothing on the exponent but there is x, it means the exponent is 1. The exponent of x is 1. Then I will have 1 multiplied by 3 exponent x as a base, and then exponent is 1, then minus 1. trying to prove if now these two things will be the same. And then going further, we will have 2 multiplied by -5, which gives us -10, and then x as a base. Then exponent 2 minus 1 is just 1 on the exponent. Then minus 1 multiplied by 3 is 3. Then x 1 minus 1 is 0. Simply, we'll have -10x minus 3. Then anything to the power of 0 is 1. Then you can see anything multiplied by 1 is that thing. That is why we say now, if we use the shortcut method, it has to give us the answer if we use the first principle. That is why I advise you that when you say from the first principle, to get all the answers or the marks correct, derive it with your shortcut method, this one, and see that the answer will be the same as yours. Because sometimes you can be doing something thinking that you are doing it correct, but then only to find out that the answer that you are finding there is not the correct one. You have made a simple mistake of a sign or of a number somewhere by a misunderstanding. So
Yeah.
even if the answer, they don't want you to of the shortcut, they want you to use the first principle, but then when in your simple corners, just use it to prove it the answer is correct.
Yeah.
Good. So if means we understand each other, then we can go to the next part of the fractions. Now is the first principle, the question, they are coming in a form of a fraction. Yes, the steps are increasing, so the standards are going higher. Here we are. We can see question number E and also question number F. They consist of the fractions. 2 of them are the same. So here, we make sure that the fraction x is multiplied, it does not become the denominator. Am I clear?
Yeah.
Make sure that the x does what? It multiplies. So if the x can multiply the whole number, or the x must have a coefficient that multiply the certain part of the equation, it's going to be easy and simple for you to understand. Let me just take 2 minus 2 over x as fx, and then I will take again a minus 2 over x to the power of 2 to make sure that the equation is balanced in both ways. Now let's work on this one. Now working on this one, substituting it in the formula, still gonna be the same. But the first thing here, let's prove it with our simple step of making sure that it is now it's giving us the answer, and which is this section. The section is something like this one. And then let's see if it's going to give us the same answer if we try our troublesome. Now we are going to be having 2 over x. Oh, it's negative. Okay, it's negative. Then the first step, we must remove this x as a denominator. Remember, when we remove a number or a variable from the denominator, it's more like saying that number multiplying by exponent to the power of 1. And I will have minus 2 multiplying by x, multiplying 2 by x, minus 2 by x. So if I multiply minus 2 by x, multiply minus 2 by x, and then exponent here, this one is going to be -1. Why is it -1? Because it comes from the denominator.
Okay.
Are we passing together there? It comes from the denominator. So if it comes from the denominator, we multiply the exponent by -1. Even if the exponent was more than, even let's say it was 2 here, it means we were going to say 2 x to the power exponent 2 multiplied by -1, which will give us -2. But let's take it as it is, like this one. Are we clear?
Yes.
Remember, the aim is to derive, but here we haven't derived yet. Now let's derive and see if we can get to the answer before we use the first principle. When we derive, we will say that the exponent of x multiply by the coefficient of x. Coefficient of x is -2. So the exponent of x is -1. So we will have something like -1 multiplied by -2. Why do I put the brackets? Because they are negative, so that they can't confuse us. Now -1 multiplied by -2 into bracket, then -1 as an exponent, and then we minus it by 1 as the principal is saying from this example, saying that the exponent itself, we minus it by 1. Are we clear?
Yeah.
Then when we simplify further here, we'll have -2 multiplied by -1, which will give us +2. And then our x as a base is, and then exponent of it is going to be -1. It's going to be -1, -1. And -1, -1, it will give us what? It will give us -2.
It's going to be -2.
Yes, -1, -1 on a calculator is going to give us -2. Yes, and then they say that in most cases, they like to say, leave your answer in a positive exponent. And when they say leave your answer in a positive exponent, they don't want their answer in this format. You're gonna get the wrong answer if you order the unfinished or unfull marks if you leave your answer in this form, because in this form your answer is not in a positive exponent, it's in a negative exponent, as we have to conclude it. And then how do we put it in a positive exponent? We now say 2. This is the coefficient. The coefficient of x, it becomes the numerator, and then divided by x. The x now, it goes down with its what is that? With its exponent. But unfortunately, now on this side, the exponent is going to be the positive one. We just say the exponent as it is, and then we put it in a positive form. Then we will have something like x to the power of +2, no longer negative. Why? Because now it has come at the bottom.
Hello.
Are we clear?
Hello.
Yes, I'm still here.
Hello, can you hear me now?
Yes, I'm here. I can hear you. What's happening? Are they kicking you out? Okay, now this was the shortcut of finding the derivative of -2 over x squared. Tatani, can you hear us? Hello? Can you hear me? Can you hear me? Hello? Can someone hear me? Hello? Am I still audible? Okay. Bumelelo, can you hear me?
Hello, I can hear you.
Okay. I see that Tatani, the teams was trying to kick you out.
Okay, look, can I please just hold for a few minutes? Maybe 5 minutes, then I just want to buy data.
Okay, okay. Wait for you. Okay, you can hear me clearly, Pumelo, right?
Yes.
Okay. Then any question from your side?
No. I'm
No
good.
questions.
Yeah.
Okay. Okay, let's get to the point of answering the question to derive this one. We have to see that the answer we will get after we derive is the same as when we say 2 divided by x to the power of 2. Remember, or the thing we did here, it was not from the first principle. It was just the stage of deriving, which is the second part of the derivative that we will use on the following questions. So here, with the first principle, it might be quite challenging or it might be quite trickier, but then let's come back here. The first principle will still state that limit x to 0, wherever there is x on the graph, we put f as we put x plus h and then minus fx all in all divided by h. Now on the substitution, we are going to have something like this. We will have 2 divided by, here's supposed to be x. Oh, it's minus, sorry. Supposed to be x. So where's supposed to be x, we put x plus h. That is the first part. And then minus, this is the minus we're talking about. And then fx, we copy the equation as it is in the bracket. We put the brackets. And then all in all divide by h. Not forgetting that limit h becomes what? It becomes 0.
Yep.
Good. Then the first part here, what do? We go back to our principles or our statements that says that when we say on the step 3, where there is a fraction, first of all, you must find the lowest common denominator. So we'll have to find the lowest common denominator of those things that are there, which is minus 2 over x plus h minus into brackets minus 2 over x. Simply will be just saying, let's remove the brackets first. Then we'll have minus 2 over x plus h, then plus 2 over x. All in all divided by h. Then we can cross multiply. When we cross multiply, we will have negative 2 multiply by x, which will give us negative 2x. Then the sign in between, it's plus. We put plus. Then 2 multiply by x plus h. Then 2 multiply by x plus h. I put x plus h in the bracket. And then divided by the denominator multiplying themselves, which is x multiplied by x plus h. These are the denominator. And then all in all divide by h, not forgetting the h. Are you back, Tatani?
Yes, I'm back.
Okay, find us on the way. And then here, what do? We simplify. How do we simplify? The top, we have minus 2 plus 2, and then into brackets, 2 is x plus 2. Then remove the bracket. When we remove the bracket, we will have something like minus 2x, which is this one, plus this one multiplied by this, multiplied by that, which is going to be plus 2x plus 2h. So all in all, divide x plus h multiplied by x, then all in all divided by h. And then here on the denominator, we say that these two are the same, they crush one another. So when they crush one another, we will remain with 2h divided by, I'm simplifying the brackets here. When I simplify the brackets here, I will have something like x to the power of 2 plus h, and then all in all divided by h. So how do I get rid of this h? Remember, now I'm going to be having 3 h's: h part 1, h part 2, and h part 3. I must remove h part 3. So when I remove h part 3, I am going to multiply everything by I'm no longer going to put h3, but I'm going to multiply everything by 1 over h. So it was the technique of mathematics to remove this h as the denominator, to put it here as an independent number. Are we getting together? That's somewhere here. Are we getting somewhere here? Good. Then the next step here is cancelling this one. Then we'll be remaining with 2 divided by x to the power of 2 plus h. And then that is where we introduce limit h to 0. Then we will have 2 divided by x to the power of 2 plus 0, which will be equals to 2 divided by x to the power of 2. Then it's done. Look at it and ask me questions. Here, let me put the screen for a few minutes.
Okay. You said 2h over x squared plus h, ne? I think is the fourth part, is the third part. Hello? Hello?
I can hear you, yes.
Yeah, that part when you said 2h over x squared plus h over h, ne? No, this other side. There, yes. So I'm trying to check there if maybe it's because you missed the other step, because I was expecting that h to be like xh.
Oh, yeah. You are right. It's supposed to be xh. So, yeah, supposed to be xh. So I was not supposed to remove the brackets. Thank you about that. It means you have a light on these things. You know them, actually.
I'm still trying.
Yeah, I wasn't aware of that one. So I wasn't supposed to remove the brackets yet until I get rid of that h. So which means here I will have x squared times x, sorry, x times x, which is simple to x squared. Yeah, you were right. Thank you for the reminder. Which means we are a good spot.
Sorry?
It means we are good to go on this part of fractions.
Yeah. This one and the other one, you're only those two. So I don't know what I'm gonna do with the other stuff.
Which stuffs?
Those other ones, you're right, and even paper tweet is my problem.
But then if we can start understanding this one, all the part of derivatives, they involve deriving. If it's not first principle, we derive the way in which we prove.
Yeah.
If we were doing this first, if you remember, we proved this to be 2 over x to the power of 2 by using the other passing method on this section. Remember, on this section, we tried to bypass the step here, and then that is where on the following questions, before you can go to but again, the functions of the cubic functions, you will start by deriving such questions. That is why I'm saying that you derive part by part. If you still remember on the previous question of this question of minus 5x, this question of minus 5x to the power of 2 minus 3x. I said that here there are the two parts. It means when you derive, you will derive the first part separately or independently, and also you will derive the second part separately or independently, so that you can end up having the correct answer. Because the mistakes that we mostly see when we do the markings, we see that candidates are only deriving the first term or the first part, and then they leave the rest as if they are done deriving. Or they derive more than once. They derive this one on the first step, and then they derive this one on the second step, and then on the last step, they derive everything.
Okay.
Which is kind of confusing. But then here, if you can simplify, you simplify everything. If your equation or your graph is not, or your statement or your expression is not simplified, don't derive anything. Just make sure that you simplify everything first. Then after you simplify everything, when you derive every part of it. Don't derive the second part, and then when you're supposed to derive the second part, you see that, or you realize that it is not simplified. You have to work on it. So you must work on every part before you can derive. Then when you derive everything at once. That way, it's going to be understandable, and you will understand where are your mistakes.